Is total entropy an extensive property? Thermodynamics Explained. Have you ever wondered how the concept of total entropy fits into the world of thermodynamics? Today, we will break down this idea and clarify whether total entropy is an extensive property. Total entropy is indeed an extensive property in thermodynamics. This means that its value changes based on the size or amount of matter in a system. When you combine two separate systems, the total entropy of the new system is simply the sum of the entropies of the individual parts. To understand this better, let's look at what extensive properties are. Extensive properties are characteristics that scale with the size of the system or the quantity of matter present. Common examples include volume, mass, internal energy, and yes, entropy. If you double the amount of substance in a system, these properties will also double. Now, what exactly is entropy? Entropy measures how disordered a system is or how many ways energy can be arranged within it. Because it is linked to the number of particles or the amount of material, entropy increases in proportion to the size of the system. On the other hand, we have intensive properties. These properties do not change with the size of the system. Examples include temperature, pressure, and density. Understanding that total entropy is an extensive property is essential for practical calculations in thermodynamics. For example, when you assess changes in entropy during chemical reactions or physical processes, the total change in entropy will depend on how much material is involved. Interestingly, you can also express entropy as a specific property. By dividing total entropy by mass or the amount of substance, you get what is known as specific entropy or molar entropy. This allows for comparisons of entropy characteristics that are independent of the system size. In summary, total entropy is extensive because it adds up when systems are combined and directly relates to the quantity of matter. This aligns perfectly with the fundamental definition of extensive properties in thermodynamics. Understanding this concept is vital for analyzing energy transformations and the direction of spontaneous processes in real-world situations.